and welcome to UNI.MINDS Festival. My name is Jana and I'm really delighted to be hosting this workshop that is part of UNI.MINDS Festival. The mission of the festival is to strengthen the industry-academia partnership and to grow the innovation community in Slovenia. You can find more information about the whole festival and its agenda at the website of the festival and also in the Huva application. You can find the links in the chat. And today's workshop will be focused on blockchain technologies and Internet of Things, and it will be led by Dr. Mateusz Pustišek. Dr. Mateusz Pustišek is an assistant professor at the Faculty of Electrical Engineering at the University of Ljubljana, and his research is focused on Internet services and application, including mobile, web, and Internet of Things. And his special interest is oriented towards Internet of Things architectures and security aspects. Recently, additional focus is set on blockchain technology in Internet of Things. And I invite you to really ask questions. You can use the chat links, or you can, at the end, ask live, and we will try to answer everything during the session or at the end eventually. So now I will give the word to Mateusz. Please, Mateusz, the floor is now yours.
Thank you. Let me share my screen with you. Okay, here we go. So as it was mentioned in the introduction, I'm going to discuss two technology concepts, the blockchain technologies that you probably know, at least from Bitcoin and Ethereum, and the Internet of Things. So there are two very relevant technological concepts, where one is rather a mature one, that's the IoT, and the other one is still fresh and very much under development. So we'll see how they fit together and how they don't. So for those of you who are not maybe familiar with the organization of the university, just a brief introduction. I'm at the Faculty of Electrical Engineering, so this is one of the faculties at our university. We, of course, do teaching and research like anyone else. But what is important, I think, for the topic of today as well, is that about half of the budget of our faculty is acquired on market. So we are definitely very much oriented towards solving practical problems of industry. And that's why we do the research that also solves the problems around us. And what are we discussing today is also a very realistic problem that various industries are facing or will be facing in the future. So I'm really glad to have the chance to lead you through this discussion. To start with, so there were many huge expectations put to the blockchain technology in the past, not just related to the IoT, but to other application domains as well. Some of these expectations were, we have to say, unrealistic, and they were motivated by or led by a poor understanding of technology, of capabilities, and of the main benefits. While on the other hand, there were some possibilities that nowadays prove to be realistic and can be explored very successfully in unique and new, refreshing ways. So this statement that I have here, this is a statement from the IEEE. This is a prominent electrotechnical organization involved in standardization, scientific publishing, and so on. And the statement here is really bold. So blockchain is presented in a way as a general remedy that is capable of solving or almost all the problems that we might be facing in the IoT. But as you can imagine, that's not really the fact. So first, let me define two terms. The blockchain technology is a technology where trust is assured by combining transactions into blocks and then building a chain of blocks which confirm the previous blocks in the chain. And we also meet another abbreviation. It's called distributed ledger technology. And definitely the most known form of distributed ledger technologies, but it's not the only one. So we can have also, for example, tangles and other forms of distributed ledger. But for today, these details are maybe not really relevant. So if I refer to DLT, it can be considered blockchain as well. So I will make no important distinguishing between those two. So this is one thing. And another one is that there are two concepts that we relate to DLT or the blockchain. So one is the centralization. So we have centralized and decentralized systems. And the other one is actually more topology related. So we have distributed systems and consolidated systems. Why is this important? Because distributed ledger technologies, DLT, it's a T of course, they are both. So they are distributed by its nature. That means that we have many independent nodes that interconnect, and we can add more nodes to the system or retrieve nodes from the system and still remain the functionality of the system. Unlike in a, I don't know, consolidated system where all the functionality is stored in one server, so it's really centralized in that form and not only consolidated. And the other one is the governance. So who is the boss, who is in charge of the system? So we can have distributed systems which are centralized. And as we'll see, cloud computing, which is a part of the IoT architecture, it's definitely centralized by its governance, because there are institutions or service providers, if you want, that we need to trust about the services they provide. But the cloud computing doesn't have to be consolidated, and in fact it is not. It's rather distributed in its nature. But still, there is a trusted owner, trusted entity that runs the centralized systems. In the distributed ledgers, DLT, and the blockchain, we have a decentralized system. So that means that the governance as well, not just the topology, is spread among different entities. So no one is the boss, and everyone can participate. So we need mechanisms in order to make consensus about the decisions that take place. And of course, decisions are related to the building of new blocks, adding new transactions in the blocks, prolonging the chain. And in this manner, with this consensus, we agree what is a common truth that no one can change, no one can reject, no one can repudiate, and so on. So this is the main benefit of the blockchain technology, of course. And what is important is, as I mentioned, that the distributed ledgers and blockchain technologies as one of the example, are both. So they distributed by their nature, and they're also decentralized or can be decentralized in terms of governance. And now let me switch to this one. Let's produce a brief architecture of an IoT system. So this is the Internet of Things. So we need a thing somewhere. So this can be your house, your refrigerator, your car, whatever. So it's a thing, it's a physical object. In the IoT, we attach sensors and actuators to such a system. So sensors are sensing the environment, and the actuators are interfacing the environment in the opposite direction. Then we usually have a form of embedded system. This is normally a very small computer, capable or not, it doesn't really matter, but it is there. It provides connectivity to the sensors and actuators, and it does some basic processing and storage of the signals and information that comes from the environment. And of course, this embedded system, it has to be connected. So it has usually a form of local area connectivity or even wide area connectivity like Wi-Fi, 4G, and so on, some communication interface. In some cases, it is done a bit differently. So we have here, it's called personal area network connectivity like Bluetooth, especially when low energy consumption is required for the embedded system and the sensor system in the device. So in that case, it connects to a local gateway. The gateway can be a dedicated device or our mobile phone. And we have then the wide area network connectivity here. So starting from there, we then use the internet to reach servers, databases, so the cloud backend. So this here is cloud backend, where the applications reside, where we can process, analyze bulk amounts of data that is coming from the things, which can be not, of course, only one, but many of them. So this is what we call the application part of the IoT, where the cloud has really an important role. This is the, or I can even extend it a little bit. This is the communication part, and this here related to the thing is called the perception part. And of course, then we can have, let me do it like this. We can have then computers or mobile devices which end users are using, and they connect to the cloud as well in order to manage their services. So this is the basic architecture of the IoT, the traditional one, composed of the 3 layers. And in this architecture, the cloud had really, or has really, huge and central and very important role. And you can imagine that if there are really billions of things appear around the cloud, which all connect through the internet to the cloud, we might start facing some bottlenecks in the system. So one bottleneck could be communication capabilities of the internet, which are not unlimited, they are immense, but connectivity, communication can become a bottleneck. And also the storage and the processing capabilities in the cloud are an issue. Because still, in that case, cloud was considered more or less a centralized system. And because the blockchain technologies are distributed and decentralized, there was this idea that the first Smith is referring to, that the blockchain is going to solve it. So the blockchain in a way could replace the backend in the cloud. And because it is decentralized, it is scalable and very performant and so on. Unfortunately, that was not the fact. As we'll see later, the performance and scalability of certain blockchain technologies, or to be more specific, of the implementation of certain blockchain technologies has its limitations. We can cope with that, but still not really in the way that it was expected in the beginning. So the second misconception here is that cloud is actually a centralized solution. It in fact is not. For example, the Amazon is one of the largest, or the largest cloud service provider in the world. It has data centers in all the continents. It has virtualized systems where you can transfer a computer from one virtual machine to another, where you can scale it easily on the fly if the demand is rising, where you can deploy the same system in a supercomputer or small Raspberry Pi. So cloud has become extremely flexible, extremely scalable, and so on. So the reason that the cloud is not going to be performant enough and that we need other approaches to do so, it's in a way diminishing, or it doesn't really prove to be that relevant anymore. But what we actually can do, so we need to look what distributed ledger technologies actually do best. And what it does, or the technology does best, is that it provides trustless trust. So let me return to this one. So this is the trustless trust. Decentralized, so there is no central entity that I would have to trust if I apply distributed ledger technologies. The second part is, or it's put in the third position. This enables a very seamless machine automation. So machines, of course, are examples of IoT devices or end systems. And with the blockchain, the machines start communicating directly to each other. So notice I presented here through the cloud, through the internet to the cloud, and then back to the machine. For example, in a case of a smart home, if in this architecture, so sensory device from the device comes to the cloud, there is some processing done, and the feedback then is returned in the same way to the actuator. So in that case, we have really a rather long delay loop and a lot of communication just for a small action that could be done directly within the house or within various devices in our home, for example. So machine automation, and we'll have more details about that later on. And another one is, this is also very, so we, or you probably relate the blockchain technologies with the cryptocurrencies. So the monetary aspect, the cryptocurrencies are just one of the use cases how blockchain technology can be used. We can have the Bitcoin and Ether because the underlying technology provides the trustless trust. So this is the monetary aspect is one of the use cases. But if we apply a similar or the same technology for the IoT as well, then we can combine the machine automation with the monetary aspect of the system. However, details like the costs of transactions and the delays need to be taken into account here. And ideas at the beginning like micropayments, payments for the IoT data. So in majority of the currently present cryptocurrency networks, this is just too expensive and too slow to be done. So machine automation with trustless trust and sometimes the monetary aspects when we need them, that's a very good starting point. Now, the second myth that we need to talk about is that we have public implementations of the technologies. So we have the public blockchain technology or public Bitcoin technology implementation. This is the public Bitcoin network. We have the public Ethereum technology implementation, which is called the mainnet. And we have a test implementation, again, a public test implementation of the Ethereum technology, which is called the testnet or Opston or whatever. So we can have public distributed ledger networks, but they had another objective, which is maybe not the most relevant for the IoT. So the key objective was to provide anonymous network participants. And with anonymous network participants, I refer to the users of the system, so the users who create accounts and make transaction and transfer, if you want, cryptocurrencies from one to another, but as well the network nodes. So in the public Ethereum network, anyone can install and add another node to the system. So let me depict this in another figure. So we have here the internet, and in the internet you can add nodes that are interconnected by the blockchain technology, by the protocols of the blockchain technology. And in that way, we get a blockchain network. So this is a blockchain network. It resides atop of the internet. The internet is providing the connectivity. So let's say that this is the Ethereum network. So if I want to use it, I can attach my client to the network. So without any registrations and special permissions. And if I want, I can add another node, install it on my computer, and I interconnect it, or it interconnects to the other nodes. And in that way, I extend the Ethereum network. And this can be done in anonymous way. This is, of course, very convenient if you want to run cryptocurrencies, but in use cases like IoT, this is not very favorable for two reasons. So first reason is that the anonymity in the public distributed ledger technology networks is assured by a large number of participants. And if you want to converge in the decisions among the large number of participants, it takes time. So the performance of such a network is not very capable. So in terms of transaction per second and transaction latency. However, for the IoT, in many cases, we actually don't require anonymity of users, because if I want to connect my industrial robots in a robot as a service solution, and if I want to provide my robot services to other participants, they gladly register because they want to buy the service and want to sell the service to them. So anonymity of the network participants is not a requirement for the IoT. If we renounce the anonymity, then we can scale up the performance. So the first or the public blockchain network implementations, they're kind of a light tower. But this is a light tower for a special use case that I mentioned here. And we can have different implementations where we do the modifications in the network operation and get much better performance for a system that we would require for the IoT. So the other systems, they're usually called private or consortium-based blockchain networks. So they do both. They increase the setup performance and they can be scaled for the performance. And at the same time, they increase trust because non-authorized users are not allowed to the system. And the third point where distributed ledger technology offers solution is simply developing new mechanisms and new protocols. So as you see here, we actually do have a variety of options how to adapt the blockchain technologies for the IoT. And to understand it even a little bit better, I will switch back to the figure that we have here. So I started explaining the operation of the blockchain network. But another thing that we have in such a network, or we can have in such a network, is a small piece of programming code. It is called the smart contract. Smart contract. And if you have a network that is capable of running smart contracts, then it does not only provide trusted transactions or exchange of trusted transactions among the participants, it also provides trustworthy and secure processing. The programming logic stored in the smart contracts. And this is the fundament for the machine automation. So for example, if I create, and this is the third part of decentralization triplet. So if I create a machine, a small IoT device that is capable of interfacing the blockchain network and using the smart contract, and if I have another similar machine, so this is the machine and this is the machine, then both machines can execute trusted logic, trusted rules based on the pre-programmed logic of the smart contract, and they can actually directly exchange transactions, negotiate, provide resources, or even pay for the resources if needed. So there is, as you see in this system, there is no trusted central application provider. We don't have it, we don't use it. It's completely distributed and decentralized within the blockchain system. And this blockchain system now has three building parts. So one of the building parts, of course, is the blockchain network. We discussed it a little bit. The other one is the smart contract logic implemented in the system. And the third one, of course, are the end user or the IoT applications. So this can be applications in the devices, or this can be applications for the end users as web or mobile applications that, again, let me come to this. So we now have the end user with a mobile or web application. Of course, this again need to be applications that are aware of the blockchain network and technologies. And in that case, we can have machine to machine, autonomous communication, and of course, if needed, communication with the user and the machines, still without any trusted centralized entity. And that's the beauty of the blockchain. So the three building points or parts, the blockchain network, the applications in the IoT devices or web or mobile, and the smart contracts, we call that decentralized application triplet. So three key building parts, 1, 2, and 3, and they together build something what we call decentralized application. Decentralized application, the app, is what really runs the most innovative blockchain applications for the IoT and other domains as well. And one of the examples of the networks that can do that is the Ethereum. So the Ethereum network is the most prominent at the moment. They have other technological achievements that can do the same. In that point, I would just like to discuss the Bitcoin technology as technology, not as a cryptocurrency. The problem is with Bitcoin is that it actually can do just the first one. Bitcoin is not a candidate for IoT application based on the blockchain technology. Unfortunately, Bitcoin is too limited in its functionality. It definitely provides very successfully the cryptocurrency, but that's more or less the limit of what Bitcoin can provide at the moment and most likely in the future as well. But as I mentioned, other distributed ledger technologies, the first one is the Ethereum, and it's then the Hyperledger and EOS and so on. They can do all the three building parts of these centralized applications. So about the reality, what can we do now about? So as you can now probably guess, so the reality is related to the app triplet, to the networks, to the constrained IoT devices, and to decentralized applications. And this is probably a kind of a state of the art of research and development in the blockchain technology that is affecting the IoT most. So in terms of networks, I was mentioning that beside the public networks, which are not really relevant for the IoT, we can set up very performant private or consortium-based blockchain networks, of course. And they really can have, by orders of magnitude, better performance than the public networks that we usually know of. So one of the research areas that our research group is very much dedicated to is selecting, configuring, testing, monitoring the appropriate blockchain network configurations that are capable of scaling for the IoT. At the network part, we have another very interesting research initiative. So if, for example, we set up a private blockchain network to interconnect our devices, which is performance, scalable, and so on. But at the same time, we would like to combine it with the public blockchain network like the Ethereum network, because it has the Ether cryptocurrency, which we would like to use, we still can combine those two solutions by interlinking them with something we call atomic swap. The atomic swap shares the trust between the private and the public network, so we can combine, for example, a solution where the devices or the machines run over the private network and the users apply the public one, so that users can pay for the services, but the machines still get a very performant solution. So this is really a rather novel research area. We have some demonstrations of being capable doing the atomic swaps, but this is a fresh solution. So the third network development is called state or payment channels. It's more relevant for the public networks, where you redirect some of the transactions directly among the participants and don't traverse the network, which is limited in its capability. So it's a kind of a bypass, but with private networks and atomic swap, I think this is the for the future more the relevant solution. So the second part of this reality check is related to the end devices. So the machines that I said were using in this case, the private blockchain network or a public one, they can be constrained in terms of processing, storage, so this means the computational, as well as in terms of communication capabilities. So if I return to the figure that we started using at the beginning, we have to zoom it. Okay, so, okay, we have it here. No, like this. So the communication capabilities of this device, so it might not be capable as the Wi-Fi or 4G. So it can be a form of constraint capability like LoRaWAN, where we just can transfer a couple of bits or bytes per day, maybe, with a device that needs to run like 10 years by a single battery. So device consumption becomes extremely important, and therefore the communication and computing capabilities of the device are low. So to introduce or to include such a constrained device into the architecture, we need to clearly define what this device is going to do and what other parts of this architecture are going to do for the device. Here we usually need to make some trade-offs between the security of the entire solution and the scalability and the capability of the device. So the research of appropriate app architecture and the possible security implications, this for us is another very important research area. And the third one is related then to decentralized applications, in particular the smart contract security. So this is the part of the app solution, which is about the programming code running within the blockchain network. The issue here is that the entire app philosophy is less than 10 years old. So this is really still an immature technology in terms of development approaches, security standards, testing tools, validation tools, and so on. So for that reason, practical implementation of smart contracts might be a relevant security risk. And the third area of our research is therefore related to the smart contract security. So as you see, we are in a way involved in several key developments and research that makes the app capable of participating in the IoT applications successfully. And this is just to make you confused a little bit. I will not go into any details. What I would like just to point out here is that we actually have a large set of viable options, the technological ones. So the Ethereum is not the only one, we have many more. And when deciding about how to design our IoT solution for the blockchain, we really have to consider many different aspects. Beside the technological ones, we have to check what is the ecosystem, what the tools that are available, are they performant, are they reliable, is the community around certain technology limited to maybe a dozen of developers, or is it a community of 10,000s of providers? So this all can be checkpoints that we need to do if we want to develop a professional production-grade IoT system. As long as we do small prototypes, it doesn't really matter. Everything is good enough. But as I mentioned, IoT is a mature system, a commercial one. It's running extremely big commercial projects and solutions, and inclusion of the blockchain needs to address this professional grade or really relevant commercial business aspects as well. So to slowly conclude, I will just present you two application domains where, in my opinion, blockchain technology can be extremely successfully applied for the IoT. So one is the anonymous machine-to-machine communication, and the other one is the authorization of IoT devices. And let me start with this one. So some time ago, we have built an IoT device. So this is an IoT device, which is actually an electricity meter and the switch. And it is fully supported by the blockchain technology. So if I, as a user, want to use this meter or the switch, I do it in a solution that is exactly like the one I depicted in this figure. So this device, this is the device I was showing you in the figure. So we have smart contracts, we have blockchain network, we have interfaces for the user which can control this particular device. It's called Sweater. It's like a combination of switch and the Ethereum, because it was based on the Ethereum technology. This one is running on, can be running or does run as well on public Ethereum network, but we have the same solution implemented in a performant private blockchain network, where the capabilities of the system are much different and really do much more just simple demonstration in the public network, and we can run it very successfully there. So this prototype system is complete decentralized application triplet. There's some reasoning why we decided to do that. So as I mentioned, we wanted to have autonomous machine-to-machine communications. At the same time, we used Ether for the payments, and we removed all the intermediaries. So in that way, machines, or in our case, our meters, became independent, and we could apply them, for example, for successful electrical charging in smart grids where decentralized energy resources need to be traded and so on. So this is a prototype that could be applied in such use cases. So one of the use cases was very popular during the Christmas, where we managed the Christmas tree at our faculty through such a system. So this is the interface for the users, where they could choose what kind of lights they would like to see on our Christmas card, our Christmas tree. They selected the duration of the lights shining, and this was really a huge success in one of the Reddit channels. So in less than a day, we got like 20,000 reads and an implementation of exactly the same system that I was showing in the figure here. So this was the sweater. Another case of the IoT, autonomous machine-to-machine communication, is a project that we are currently working on, and it's related to robotics as a service. So in that case, robots become independent devices that can trade for services directly and independently. And in that way, using the robots is not just the physical machine that you sell to a customer, but you provide the robot service to the customer in a very transparent, secure, and monetarily successful way as well. So this is another machine-to-machine related use case from the past. Now, the second application domain is related to the proof of existence. So with the trusted distributed ledger technologies, we can set proofs of existence. We refer, of course, to the existence of different electronic documents or electronic resources. And for the IoT, in that way, we can create management of the IoT devices, of the configurations, software updates, and so on. So this part, the management of IoT devices, including the authentication and authorization, is really a problem once the number of devices scales to thousands or millions or even more. And here, definitely this decentralized nature of the blockchain technology, and most importantly, the autonomous machine communications that it provides, it solves an important challenge that IoT nowadays has. So this is a part of our previous project that we completed. It's related to the providing proofs of existence, and it can be and will be adapted for the IoT as well. So now it's the ultimate slide that I have here. But before I conclude, just let me return for a moment to the initial one or the second one. What blockchain can do and what cannot do. So reducing costs, excuse me, I was not meant. Reducing costs, I wouldn't say so. It makes things maybe more complicated. It does reduce costs to some extent, but that's not the key point. It definitely builds trust. Accelerating transactions, I wouldn't say so. We have better ways to accelerate transactions in the IoT, including fog and edge computing, which do their job better than blockchain would do. It provides scalability, yes, to some extent, not really that efficiently. About single point of failure. So yes, of course it does it, but modern cloud computing do this as well. This is what probably is very important. Immutable set of record with no trusted parties. This is a big one. And enabling the machine-machine transactions for autonomous machine-to-machine communications, this is a big one as well. So from the IoT or from the blockchain for the IoT, we don't expect the usual services that we otherwise get from the cloud computing, like bulk data storage or huge computing capabilities. It's where trusted exchange is needed and automated machine-to-machine communications are required. This is, in my opinion, the best way to combine the blockchain and the IoT. So that would conclude my presentation. I thank you a lot, and I'll have a look at the chat now to see whether there is some
in the chat. Urshka is mentioning she's actually inviting us to check a case, a Slovenian case, and she's asking for the feedback from our side.
Just let me have a look.
And of course, I think everybody now that has question is invited to maybe unmute and ask, and we can listen to the question and answer live.
Okay, yes. I'm looking at the questions. So maybe Furska wants to add some additional comment.
Hi, no, just I was just because thank you first for letting me discuss this, but
like maybe you can turn on the camera if possible. Hello.
Yeah, sure.
Hello, yes.
So, like I said, this is not an ad, but this is a really good use case, which we also are showcasing also to the practice in the market. So, our guys at Abelium, I don't know if you know them, but probably you do. We are
yes, we do. Yes, yes.
kind of involved with the universities also. But just like you have presented the possibilities of the technology, this is how also our team tackled this issue. And so this is the MVP of the possibilities, where can we go? And this app is actually now running on the market last 2 years. And we have already first good customers. But from your perspective, what would be interesting is what else can be done in the future. So we are also exploring now those swaps that you mentioned.
Yes.
And also the Ethereum, we see much of the possibilities of going in this direction, so smart contracts and so. And here is kind of a playground where we can all evolve further. So if there will be interested also from your side and the universities and the participants here, you are welcome to ping us and we can discuss what can be done. Because like I said, we would really like to make things for the market. So this is actually something that can be shown and done. So not just in theory. So welcome all. And like I said, if you would like to test the app, welcome, but I'm not pushing any trading or something. So
yes, yes. So yes, thank you for the comment and presenting the ideas and the results that you have. The fact is that till 2018, so blockchain was a victim of its success, and the success was, of course, related to the cryptocurrencies and the boom in the prices. And that in a way maybe made many forget that there is the technology and there is the use case, which is cryptocurrency. It was really important one, of course, and I agree, and it still is, but it is not the only one.
Mm-hmm.
When we start discussing other use cases like use in the IoT, then we find that different issues appear and that even we might have different options to cope with them. For example, there is a set of tools and technologies and protocols that is called Hyperledger. It's also blockchain technology, but it doesn't run cryptocurrencies because it is not meant to do so. It's predominantly meant for the IoT. And the development, of course, is maybe not that prominent, that not everyone is talking about, because there is no cryptocurrency, but still they attack another application domain. And since 2018, there has been a lot of development in the business environment going on in order to adapt the blockchain technologies for the IoT, among others. And the results that Urška was presenting here, for example, is one of them. In their case, for example, what is also good to know and be aware of, you can use almost the same technology, the Ethereum, for example. So Ethereum technology applied in the public Ethereum network, it is capable of doing like 1720 transactions per second, which is really a very, very low figure. But it is not the case it was designed for. So the public Ethereum network is predominantly meant to run the cryptocurrency and smart contracts related to the cryptocurrency payments. If you apply almost identical technology with certain modification in a private network, then you can easily reach thousands or even 10,000s of seconds per second with the same technology. So it's the matter of configuring and implementation. And especially if you add these special new developments like swapping of transactions between public and private networks, then this landscape for application development, other from the decentralized finance, is really opens. There is a lot of research going on in this direction.
We have one more question just popped up. It's from Maya. She's asking if there is special informatic, if there is a blockchain research group at the faculty that students can join. She's actually a student at the social informatics student.
So yes, we are not the faculty of computer science, so we are faculty of electrical engineering. Yes, we do have a research group that is dedicated to blockchain research. So this is the group that I belong to. Of course, blockchain is not by far not the only research domain that we cover, because our laboratory is quite a big one, and in total we are 40 plus members, so we cover different research aspects. But the blockchain is actually organized as a form of research group, and I would say we have 2, 4, 5, 6 members in this group, including employees or full staff and some very capable students. So if Maya has a wish to discuss it a little bit, she can contact me and we can see what we can do. But of course, it's another faculty that she has to know.
Thank you for your answer.
Yes.
Is there any other question from anybody else? So you can also unmute yourself. And
we have another one. Yes, we have another one.
Okay.
Nate has a different one. Yes, what is the difference between a private network and a distributed cloud? So yes, in that case, if we actually have just one institution running all the nodes in a private network, that in terms of decentralization is the same. I agree with that. Yes, that's true. It's not a problem that if you create a private network and you openly acknowledge that it's a private one, then it's, I would say then the reason to use that is that you, let's say, start developing a solution based on the private network, and once deployed into a real environment, it can become a consortium network where the level of decentralization is bigger and security and trust is bigger as well. The problem is that many public blockchain networks actually are private networks. So this is a network where all the nodes are managed and controlled by one single entity. And you have private networks which run billions of dollars worth cryptocurrency, which in fact are centralized in its core. So this is the biggest issue, I think, the big issue. So this is also one of the criteria that I mentioned, that when you start looking for the options, so what your background technology is going to be, you have public networks that claim extremely good performance, extremely high transaction rate and low latency and so on. But if you look into a little bit of the detail, you see then that it's actually not a public network, but it's completely a private one, which enables public access to the blockchain services. So Nate, you are completely right. You have to look into these details when you decide what your underlying technology for your business grade system is going to be.
Okay, thank you for your reply. I will just briefly thank you, Mateusz, for this really great insight.
Okay.
And I will just shortly wrap up. So as you I see there has been a lot of interest and also quite some questions, but yeah, time flies and we have to, wrap it up and finish it. But there is a possibility to continue the discussion in WHO application, where you can create discussion topics. You can also create meetups and share articles. So please be welcome to use it. And Thea will post the link in the chat. And also it would be a great help for us if you can rate this session. It will help us to do better in the future, and you will also see in the chat the link to the rating. And of course, not to mention, this lecture was organized by the University of Ljubljana and University of Maribor by Knowledge Transfers Offices. And of course, we also had some sponsors and partners, and the whole event is co-financed by the Republic of Slovenia and European Union under the European Regional Development Fund. Our festival is still running on, and this week we have a lot of sessions, so please check the agenda. There are quite some interesting topics. For example, today we have another workshop just today in the afternoon about creating strategies. Check what feels where you feel more passionate about, and we'll be happy to see you again. So this is it for today. Take care, keep an open mind, and see you at our next session of UNI.MINDS Festival. Thank you.
Thank you very much, and thanks for your attention. Goodbye.
Yeah. Bye-bye.
Bye, thank you.